All right, I'm back. The reason why I'm back is because I wanted to expand a little bit on the short circuit video that I did last time. I didn't exactly get everything that I wanted to get across in that video, so I'm redoing it here, and I'm just going to leave the other video up, and we'll just go with this one. Um, what we have here is just a single phase line coming in, 200 amp service, 120 volts coming in. On this side, we have my shock-free device, which doesn't draw any voltage, doesn't draw any current, and there is no power being put through this device at all, unless you short circuit yourself from here to here, and then then you've made yourself a parallel load, and then this device does come into series with you. Um, Here is a 15 amp circuit breaker, which I've never been able to set off. By the way, I've never been able to trip it. So the maximum current that I've drawn through with a short is approximately 26 amps, and this 15 amp circuit breaker has never tripped. The load that I'm using is a 1550 watt heater. With this circuit in here, under 120 volts coming in, it draws 118 volts, and its current draw is 118 volts is dropped across the line, and 13.414 volts is drawn through the load. So with that, the current dissipating device or the heat dissipation device draws 400 or 0.44 watts of power, which is just a little under half a watt of power. 2 volts of electricity are dropped across the line, and it draws 0.22 amps of current with 0.308 ohms of resistance. The main load has 0.809 ohms of resistance. So with load 1 plus load 2, we have 1550 ohms, 1550 plus 0.44 watts, and 120 volts is equal to 12.92 amps, and the total resistance seen on the line is 9.29 ohms. Okay, now we've covered everything here. Everything has been covered in its technical aspects, so we know what everything was going on. Now with the short, what I was doing was coming from here to here, from hot in to neutral, and all that was happening is that the current was just coming through here, and so naturally the current dropped here considerably. It dropped as much as 8.45 amps. And you would expect it to drop somewhat. The total load is 12.92 amps, so you'd expect at least that. It dropped well below that. I expect it's something to do with the heat dissipation device, but I can't prove that at the moment. If you short across the load, which is what will normally happen in real life. In real life, this is very rarely going to happen, and if it does happen, this is going to be caused by water, or the electrician did something very stupid. Mostly what's going to happen is you're going to short across the load. So when I did that, and I had my meter right here, I saw the full 20 amp draw coming through the load from here to here. Okay, because I have my amp meter right here. And I would expect the same thing right here. If I put my amp meter right here, it'd be pretty much the same thing. This draws a little less than half a watt, so about a quarter amp, really, just about a quarter amp. So whatever's coming through is seeing most of the current going through. This is just drawing a little bit in and of itself. So when we short here, everything in back of this load is still dropping in current. The main current is going through the short and back up through my device and into PG&E. With the 240 device, it's a little bit different because we have to hook the device up onto the power line. So there, it's a little bit different. the load seeing this device in front and in back, but the device is still drawing less than 1 watt. It's got the whole thing put together would be only 4 volts drawn put across the device, and so you'd be drawing almost a half an amp of current, and with the two devices on a we'll say a dryer or an oven or something like that. Actually, with an oven, I don't know if I would put it on an oven. That would have to be tested. The device does take quite a bit of heat out of the line, and the oven may work properly, but it might not get as hot as it normally would. So that would have to be tested. All those things need to be tested. Really, I didn't have the capacity to do all that. Anyway, I guess I'm through pretty much. I just wanted to make this for proof, basically, that these devices are mine. It is being time-stamped on the YouTube and on other social media, and I had to make this really clear up a couple things. I'm being asked to leave my property, and I'm going to be homeless here pretty soon, so I just wanted to make sure that everything got put up and in place so that when that does happen to me, I'm not going to really have means to be getting online and doing all those things anymore for a while, it looks like. So I wanted this to get up and so things can be cleared up, and hopefully I can get something going. I'm not getting too many views on the video, so I'm not sure if people are thinking that it's a joke or what. Trust me, this is no joke. The devices are for real. I'm not being shocked. I'm not switching switches. There's no hanky-panky going on. I'm willing to prove this to anybody and everybody at any time. Right now, I put my inverter in my car, and I got one of my devices hooked up to the inverter. It works just fine through the inverter, just as well as it does to the panel. It's exactly the same. I can still cross the load, no problem at all. So anyway, with that being said, I hope you people understand that this is for real. I'm not lying about it. I have no reason to lie about this. I'm not asking for any money from anybody. So with that, I bid you a good day and be safe, and I'll talk to you next time